Welcome back to CodinGame, Fall Challenge 2023. Continuing with this seabed security stuff. So we're still in Silver League. Last time I had some ideas for what to change. Let's have a look. So there's one thing I want to do immediately. Well, okay, let's have a look at the to-dos. What the? Oh, Legend League just opened right now. Interesting. So we're going to see a large... Well, no, nothing will change in Silver League, but in Gold League, there's going to be a lot of people promoted now. All right. So, yes. This is what we want to do now. So when an enemy scans a fish, we get information. We see that on our input. We just have to interpret it. Account for monsters. Yeah, that's a flaw right there. So that needs to be done. We'll probably do that first because that's actually a bug to do. If enemy scans a fish, we get a known disk of light radius for the position. Yeah, that's what I wanted to do. I'll put that in two places. Alright, whatever. That's not supposed to be done here. Take that out. Go to position to capture most scans. Handle sides of grid. Yeah, okay. Why is this? Vector equals drone.pos minus close dot. Oh yeah, I said last time I left my code in a broken state, didn't I? We need to fix this. Closest dot get. So the method we want is get predicted pos. From now on, we only predict poses. We don't know the pos. We do know the pos if the prediction has to be 100% perfect, which it is when the rectangle is of 0 size. Will the code actually run? Oh god. Alright, there's a bug. Why are they both going here? Well, this exact spot. 8552503. Where's that? Alright, something's very, very wrong. Did I make sure to change all the... Set bounding box based on last bounding box. Yeah, we want to do that as well. An enemy scans a fish. Yeah, okay. So, alright, we've got a bug. What are they doing? Searching for fish? Still doing that, we can turn that off for now. Well, yeah, no, we'll turn it on. Pick closest fish and hunt it. I think this is a problem here. Let's log the ID number that we're chasing and the location. I think predicted pause is just wrong somehow. Alright. 4. Predicted location is x1000, y1500. Yeah, I'll put all the things on. Well, that's very wrong. How did that happen? 1500, it doesn't even want to... Alright, let's figure this out. So probably let's go back to the rectangle stuff. Get center. That's that over 2. Let's try logging this. So log self.t1. Let's just do this. Okay. Self.bottom right. I want to see if we're actually getting to the center correctly. TL. Well, okay, this is a lot of logging. So top left, bottom right. So yeah, that looks like it's halving between them. $2,500. Where are these? Okay. Fine. Center is fine. I think. To intersect is another important one. So if I've got a top left and a bottom right, what is my new top left? Between 2 rectangles. So the x value will be the max of the 2 x values. The y value will be the max of the 2 y values. Oh, bollocks. What is this? Yeah, we're using the top left again. Why did I copy and paste that? Because that's... It's gonna be bottom right. Bottom right, so you got the min x and the min y's. Try that now. it better. Okay, I don't see any bugs. So... why are we zigzagging now? So we're changing our mind about which fish to go to. That could be a problem. Like, if you can't decide which fish to go for, but you're between two fish, you might keep flipping back and forth between them and not get either of them. It would be better to just pick one and stick with it. I'm not sure how to handle that right now. Okay, so that's fixed. Also, let's just fix the bug with the monster. So monster is getting the wrong bounding here. So if self.type is -1, it is -1, isn't it? Yeah. Then it's between 2,500 and 10,000. But we actually know it starts at 5,000, so. We can put that information in there as well. So, oh, no, it doesn't start at 5,000. It starts... it starts at between 5,000 to 10,000. But eventually can reach 2,500 to 10,000. Okay, makes sense, I suppose. So... we can take that into account. So in general, be so 0, 2,500. You're not allowed to be on 10,000, are you? Are you allowed to be on? Ever been assuming you're not allowed to... Oh, you might actually be allowed to be on... No. Units on each side. So... It would be 10,001 if you were allowed to be on. Okay, that's fine. Yeah. It's fine then. But we actually want that. Don't we? But for the other boundaries, we actually can be on the boundaries. But I'm guessing for the... That should actually be 9999. So these boundaries, they're allowed to be on the boundaries, I think. But the final boundary, they can't because that's not even on the map. But there's no cells for that, I assume. I don't really know. Doesn't matter, I guess. I can just say with. I mean, tell you what, let's just do this. Make this a dictionary. Go 0 maps to so 2,500 to minus 1. 1 maps to this. 2 maps to that, 3 maps to that. Let's do that. How do you indent it appropriately? Is that fine? I don't know if that's fine. Don't want to make it too long. Alright. 0, 1, 2, 3. So now... it's just what we had before. Right, so now we have a better, we correctly put the... Oh no, that's wrong. Hang on. -1. There's no 3. No, there is a 3. No, there's no 3. 0, 1, 2. 0, 1, 2. Yeah. Okay, fine. We have a better... We now have a better box for the monsters. A correct box for the monsters. See, this one, you don't really interfere with the monsters much, and there's no reason to go near them unless you get led there. Okay, so that fixed that bug. Alright. So at this point I kind of want to submit it because we did a lot of stuff and fixed a bug, and I just want to see where my position is before we start changing the logic. Let's test an arena. Just leave that alone. Alright, so what do I want to do next? Set bounding box based on last bounding box. Okay, this one's a good one. So what I'm saying is, whatever the last bounding box is, let's grow it depending on the fish's max velocity. So if they could be in this box before, then they could be in this box next turn. Just expand it. And then yeah, so how do we do this? So right now we're resetting their bounding box. That's fine. I would say alright, let's do this. We want a new method, which is grow. So we will scale, I don't know. Are we losing lots of battles? We are. Let's check these because it might actually be, it might be crashing. Yeah, it's crashing. Creature object has no pause. Oh, bollocks. I forgot about... Yeah, I mentioned this last stream. I left it. I should have put a note there. It's within radius. Oh, for goodness sake. Alright. Here's what we do. We just stop using pause anywhere and just have get pause. Alright. So that this is named the same. So creature get pause. This is, but we do want to differentiate between predicted pause and no, it's fine. Alright, we call it get pause. Alright, and drone will also have a get pause. Okay, and now never use pause again. So it's going to be a dot get pause dot dis to b dot get pause. I think it's just do it like that. All right, so we've okay, but it's going to be hello, Mara. I'll go Subnautica. It's going well. I have some interesting ideas on the horizon. I just need to and get them done in the next 2 days, 21 hours, 33 minutes. I don't like this. This is... Oh, that's fine. So get predicted pause is renamed. Oh, can't be renamed. Okay, just change it to pause. Can we do it? Find and replace then. I carried on with Doom yesterday. Oh, I think you were in my stream briefly, weren't you? But I got stuck on the second last level. It's bloody difficult. Well, it's one of those levels where everything's fine, but you have to go through a lot of things, and then right at the end they throw you into a trap room, which you can't get out of, and then you've got to fight for your life. But it was really nasty because it's like lots of Mancubi, an Archvile, and lots of Pinkies, and lots of Cacodemons. Yeah, I have the new Wheel of Struggle coming up. It has been announced. Pokemon Gold. I might even start it today. I'm actually quite excited to do it, but the thing is, there's a lot of confusion about the rules. It's like they're changing the rules. Well, the rules have been modified multiple times in the last couple of days. You can never really pin down the rules for Nuzlocke. They're always complicated. So it might be better just to wait until that's figured out. I'll just change this. Do this. Okay, whatever. We're doing it now. Alright, so now I mean, it's good practice to have get pause methods rather than accessing pause directly. Just gotta poke some mans. Mans? Is that supposed to be mons? Oh wow. That let us ace that match. Okay. So, that fixed that bug. Alright, submit it again then, because our code was just crashing. Yeah, it seems like an interesting game, but I feel bad for any of the Wheel of Struggle people who haven't played Pokemon before or don't have much experience, because it's not an easy rule set to understand, especially when you haven't played Pokemon before. I anticipate a lot of people will just be dying early before they even get to the first gym. At least you can restart the game from scratch if you die, if you lose all your Pokemon. So you can always replay the game from scratch. It just means you have to go through the intro again. Okay, so let's fix that. Let's check what's on the list. Alright, so what I want to do now is... Ooh, okay, our rank's gone up. Alright, so I want to create a method for scaling the rectangle. So if I say I want to scale the rectangle by like x, well, no, it doesn't say x, by k, because x is a horizontal variable, then I increase the boundaries by k in every direction. The idea is if they could be in a rectangle this turn of this size, next turn I'm saying, because it could have moved from the boundaries, I now want to increase the rectangle. Now the slight issue is that if they were on the corner, in theory the corners should be rounded. But let's not do that. Let's just make it another rectangle. So now what is the geometrical term for this? It's not scaling. Scaling means it goes up by a percentage. Well, it is sort of scaling, but projecting, no. Scaling might be correct, although scaling normally means if you scale by... No, scaling is not the right term. Scaling means you scale from a certain origin, big or smaller. I'm decreasing or increasing by a fixed quantity. So, extend. Extend might be the right word. Yeah, because I wanna emphasize that I'm just adding a fixed amount to this rectangle in all directions. So if we extend it by A, or no, don't use A, just say like delta. Returns. We create a new rectangle. So the new top left is going to be top left minus pos delta delta, and the new bottom right will be bottom right plus pos delta delta. Nice and easy. Alright, so if we extend, alright, reset bounding box. Okay, I want a method here. Define get habitat. Get the habitat for this fish. So it's actually just this. But I'm going to be needing this method. So reset bounding box would be self.get habitat. So that gives us its max zone where it's allowed to be. Okay, make sure that's still working. And then, why do I want to do that? Basically, I want to say we take right. I don't like this phrasing here. Update bounding box. That would imply we update the bounding box to be B, but clearly I'm not doing that. We should just call it intersect. Wait. Yeah, intersect. Just be completely explicit. So let's say alright, better naming here. Okay, so so at the beginning of the turn, oh, it didn't actually. If creature.bounding box is none, why would it ever be none? Oh, that was a relic of a past thing. Okay. That out. I assume that's fine. We always have a bounding box, and at the very maximum, it would be the full habitat. Okay, so now, okay, so here's the logic here. So for each creature, do we have, I think I said I wanted a is in map. Alright, so is in map is true to begin with, definitely. So we want that. If is in map false, then we just ignore this right now. Alright, so if not c dot is in map, skip this one. Alright, so we want to say if c dot So when we create the creature, we give it an initial bounding box. Okay, so it has a bounding box always, unless we've just discarded it from the map. Okay. Old box equals c dot get with c dot bounding box. So what we do is we grow. Wait. No. New range equals c dot bounding box dot extend. We need a... Hello, Dread Soldier. You plan on using something like min-max? Min-max. I don't think min-max really fits here. Min-max is more like for two-person games where you take a turn, then they take a turn, then you take a turn. Like tic-tac-toe and stuff like that, I think. I don't normally call it min-max. I normally think of it in terms of like depth first search or breadth first search. So if I'm understanding what you mean by min-max, I don't think... I would, no. It's more a game theory thing, which, I mean, this is a game, but it's not a turn, it's not a, yeah, it's not a turn, it's not a game where it's the opposite, like you're trying to maximize your score, which is the same as minimizing the opponent's score, which in turn is the same as maximizing your score in the next turn, and so on. I think that's why it's called min-max, because the minning or the maxing flips depending on whose turn it is. Therein lies the recursion. But your min-max could also imply denying point S for the enemy by dragging monsters to them, or kind of these things. Yeah. But I still don't think you would call it min-max. I think it would be... I think that's just basic heuristic strategy. I don't think min-max is the right term, because you're still not taking it in turns. I actually don't know. I don't actually use the phrase min-max often. I prefer to always think of things in terms of the search algorithms I'm using. But, okay. But assuming your question is, am I considering denying point S for the enemy? Not right now. It seems like an advanced strategy that I'm not ready to get into yet, and it might have a little payoff compared to the other things I can do now. So I don't know if I'll get around to that within the 2 days. I mean, that's smart stuff. So you're saying like lure the monsters towards them, or what I will do probably is scarefish away once I've already collected all the points I can. I'll just go around and scarefish off the map. Like, there's no reason not to do that. There's no risk, and there's nothing to lose. So once I've got all the points, I'll just go around and scarefish. That sounds like a funny thing to do, and it probably... The thing is, if you've got points that early, got all the points that early, you probably won anyway, but there's no reason not to go around scaring fish, I think. Just in case the opponent is just about to catch up. So I'll definitely do that. But I don't think my code is strong enough to do what you're suggesting about luring monsters to the enemy. I think it's... Right now it's more likely to end in my demise. So max velocity. I want to set max velocity. which is a pos. No, it's an int. Should say max speed, just to signify that it's not a vector. So self.max speed equals, so basically there's two speeds. If you're fish, then what is the maximum speed you can go if you're fish? So they move 200 each turn in general. But when it's frightened, it moves at 400. So I think the answer then is 400. So 400 if self.type is not equal to -1. Else, if it's a monster, then .540 is its maximum speed. 270 is its general speed. So we'll go with 540. Okay, so my idea then is if... Okay, so we take its bounding box, and each turn we extend it by its maximum speed. Because then that bounding box is now bigger for where it could be. It could have moved at max speed in any direction. Let's just assume the worst case. So new range equals that. So then do C dot reset bounding box. So reset it to be the habitat, and then do C dot intersect C dot. Sorry, was that? I don't get it. Are you referencing something? Or was it coming up in my subtitles? So C dot intersect bounding box new range. Okay, let's be more explicit. Extended box equals that. Now we intersect bounding box with that. Alright, we've done that. So now we have a more restricted range for where it could be. Let's try that now. That massively reduced our score. Oh, it's bugged. What the heck? Wait, what? My opponent is doing it as well? What? Danny the Champ. Is that a reference to Roald Dahl's? It is, isn't it? Roald Dahl's novel, Danny the Champion of the World. was a great story. I liked Danny, the champion of the world. It was one of Roald Dahl's novels that didn't involve any magic or like supernatural stuff. It's just about a boy who lives with his father who wants to steal pheasants from a farm that down the road. They want to steal pheasants from his farm. And then he comes up with a strategy to steal the pheasants by drugging them. And then he's champion of the world because he stole a bunch of pheasants. They give him back afterwards. What is going on here? How does this even happen? Why are 3 of the drones going there? So why is my opponent doing it as well? Is he just... It could be because he's just copying what I'm doing. Ah, because I designated -1 as... Okay, we need to fix this. Don't go to -1. What am I logging here? Target fish equals min target fish dot get pos. Unscanned fish. So we've got a fish that's... This is why I don't like having valid pauses. But at invalid locations, I'd rather have a none here. Oh, I could just do that. Yeah, let's do that. So, creatures... Let's see, creature. Pause. Wait, how did this even happen? Bounding box. Okay. Exit map. Is in map is false. Bounding box is that. Let's just set this to none. Alright, so we're gonna have to change this because it doesn't like rect being a none. It's gonna complain now. Oh, it's not going to complain. This is just the IDE complaining. Alright, fine. So exit map. Are we actually using exit map? I think we might not be using it properly. So if it's in map, if it's exit of the map, we set that to false. And... we should never ever use this fish again. So are we actually doing that? C in creatures dot values, blip to creatures. C dot exit map. Yes. Okay. So we are exiting the. So we did exit it. It's got a location off the map. Is this just a massive coincidence that our enemy happened to do that same error that we had, where he's going to -1/-1? That's insane. Okay. But wait. Something was still wrong here. Because, okay, we fixed that, but why was that happening in the first place? So what was happening was, here, we were getting a fish that was off the map. Which means it was coming through in unscanned fish, which is... oh no. Okay, so we need C in creatures values if C dot is in map and C dot type not equal to -1, and okay, we don't need this one. Alright, so we weren't restricting to creatures which are still on the map. So that fixes that issue, but my enemy here has the exact same bug. That's such a coincidence. Alright. So that's that. Okay, we could take that out. Okay, so now what? So we've now got a tighter bound. Let's try a different seed. What is he doing? Okay, he's always doing that. That's why we were beating him anyway. Alright, 64.2. We did pretty well there, but see, we get kind of... Alright, let's submit that, because that was a major fix. Alright, so... Hello, Tanvir. Okay, a few wins. Let's take a look, see if we're still getting any crashes. What the heck? Look at that clean sweep. He just goes down, he scans every fish in one go and goes straight back up. I mean, that's what we aspire to be one day. That's insane. This is like, that's a speed run. Scan them all. Straight back up. This one, he's guessing that this fish is over here, so he's moving a bit. Oh, they're mirroring. Some people do this. They have their drones mirror each other's location. I don't like the idea of doing that. Like, I get that the fish are all symmetric to begin with, but they won't always be. So you shouldn't really be mirroring. Okay, anyway. What else? Okay, so there's one other thing I wanted to do, which is quite cool. That is... Alright, it's going to take a couple of things first. So, when an enemy scans a fish, and we're far away, he's given us information. He's told us where that fish is. Roughly. That fish is within that square around him. So we need to add that to our information. All information helps. Alright. So just having a long think. Okay, so yeah, I want to do this. Is there anything else? Yeah, okay, so what do we do here? I think to begin with, we need to give some more So when we get the drone in the input, we look at its battery, but we also look at what its battery was before, and we infer whether its light is on or off. We can do that for our own drones as well. We don't even know. We're not even told whether our drone's lights are on. We actually have to work it out. Either remember because we told before, but we don't know if that order went through correctly though. We might have tried to turn the light on when there wasn't enough battery. So we only really know for sure if our light is on, and it matters, if we check the batteries. So then that means we're gonna have to. Okay, so update the creature locations. Do something about the drones. So we basically want a map that maps drones' ID nums to the battery levels. So say old batteries equals so it'll be like D to when we start off at 30, okay, we know the drones are numbered 0, 1, 2, 0, 1, 2, 3. That's the old battery level. So at the beginning of the game it starts at 30. Just say we should really just make more variables here. Okay. So we've got the old battery levels. So now we see its new battery level. Alright, so we want a new variable here. For drone, we want light is light on, which is a bool. So here is light on equals. So it would be true if battery is old battery. Let's call it battery, not batteries. It's a map. Old battery drone ID minus light charge, which is 5. So if it's what it was before minus 5, then we've just deduced that the light is on. Right, so we can give that to drone. So now we know if its light is on. That means we know the scan radius of the Alright, when we do this, we also need to say old battery drone ID equals new battery. Just update that. Okay. So now we know if its light is on. I mean, that's useful information. Oh. We have to copy and paste this here. Fine. It's not ideal, but... Also, let's just say drone equals that. So the other thing we want to keep track of is the old scans. So it's going to be like this. It's going to be D to an empty set. So, this to do is in the wrong place. Actually here. Okay. When does the scan take place? Let me look at this again. Okay. Drone moves, then the fish move, then the scan takes place. So the scan is the last thing of those things. So if we see a scan, we know right this moment now the fish is within whatever. It's not like the fish had a chance to move further after that happens. That's good, because that pins down the location better. So you can say so is it possible for us to scan something without currently seeing it? Not really, because if we scan it, then we're seeing it, right? Is there any situation we turn on and off the lights? By definition, pretty much, if we're scanning it, we're seeing it. So this next turn, we'll actually see it invisible in the visible list. All right, fine. It doesn't matter, but basically we can say if we see a scan appear here. Okay, so check for new scans since last turn. Alright. For F in, so it's going to be old scans. So it's going to be, no, it's going to be, drone.scans minus old scans drone ID. So for each new scan, we can say that fish must be within radius. It's going to be light radius big if drone dot is light on. So this will be previously been defined. Else small light radius. Yeah. So if the light is off, it gives us a better bound on the fish. Why doesn't it like this? So given this, so because this is a circle, but let's make a rectangle out of it instead. The bounding box is going to be rect. So the top left will be drone.getPos minus pos. Hang on. So the top left is going to be drone.getPos minus pos radius. And the bottom right will be similar, but with plus. So we know that the fish lies in this rectangle. So then we can simply say for this fish, we can intersect bounding box with B. Finally, update the old scans. Old scans drone ID equals the new scans. Alright, see if that actually works. So every time we see an enemy scan something, that just narrows down our locations. It just gives us a more accurate... it's probably gonna crash. Or not. Okay. Well. Fine. That's good. Let's use all the information we can. Is there anything else? If an enemy goes into emergency mode, or even if we go into emergency mode, I mean, if we go into emergency mode, we would see. Monster. Well, anyway, we get knowledge that the enemy must be within a certain radius from the monster. So that will help us narrow down where the monsters are. This may end up being more useful than the fish one, because we really kind of want to avoid these monsters. And early on, we've got very vague bounds for where they are. Basically, they are within this rectangle here. Oh! Hang on, there's two things I need to note down here. One, so we're not using emergency, so we need to use that to do. If new emergency used to infer location for monster. Problem is we don't know which monster caused the emergency. That's yeah, what do we do with that? We don't want to just lose that information. It's told us that there is a monster in this spot, but we don't know which monster. Do we care? So the thing about monsters is we don't care which monster is there, we just care if a monster is there. So maybe we should be thinking about danger zones instead of this monster is here and this monster is here. Yeah, I'm not sure what we do with that information, because it kind of breaks the contract of what we're currently doing. We're currently trying to narrow down the location of each monster. Which is, I mean, we should, because that's what the radar gives us. The radar gives us information specific to each monster ID, so that we're using that information to the full extent. But this information here gives us vague information, but it's still important, so it gives us a stronger guarantee that there's a monster in this rectangle, basically. And we can intersect this rectangle with our previous bounds. Alright, figure out what to do with that another time. But we do need to do something with that. The other thing I want to do is set the initial location for the monster, because we haven't done that. So, when we reset the Alright, I think reset bounding box, I don't think anyone's using it except at the start, so Alright, there's a problem here as well. We shouldn't be doing this on turn 0. On turn 0, they didn't have a chance to move. So, this is all invalid for turn 0. This. Alright, so if it's greater than 0, that means they've had a chance to move, so we update all the creatures according to their max speed. We should say if game turn wait, no. This should just be what we initialize. Alright, we don't need to do that in the game. We just say, when we initialize the creature, we reset bounding box. Okay, but we make an exception. If self.type is -1, we intersect the bounding box with, we just say self.bounding box equals rect. It's gonna be... Well, okay, so it'll be pos 0. So they said y will be minimum 5,000 to begin with. It's going to be from 5,000, not 1,500. Like that. Otherwise, it would normally be this. So yeah, it just gives us a stronger bound. And then from that point on, so on the first turn, nothing happens. And then from then on, we always kind of increase that box. Even though we know it's static and it won't move for a while, for the first few turns, it doesn't matter. We kind of increase that a bit, so we know it could be a bit higher each turn. And that's like, we'll just keep doing that. Alright, see if this all works. And I might submit this now because it's like, we've got much more accurate locations for both fish and monsters. I mean, Bumble Squat is pretty good in his movement here, so don't worry about that. In fact, try on a different... Try one where the monsters actually get triggered. Wow, we dominated that one. Nah, he got caught by the monsters. So basically our paranoid strategy works better when there's lots of monsters and they're quite high up. Well, they aren't that high up here, but they could be higher, but it's still, yeah, pretty good. Alright, we'll submit that because that's a few nice things changed. 431, that's a decent rank. Alright. Right, while we're waiting for this to calculate matches, let's just take a quick break for a couple of minutes. Okay. How are we doing? 492? It's alright. We'll check some of these losses, make sure we're not getting errors. Giganoid. We're doing alright there, just not good enough. But we're being really paranoid still. We have to until we have good escape code. See, my opponent actually got caught. I didn't. He still wins though. Okay. Well, I mean that's fine. I just want to see if there's any battles I lose where I outright crashed. I don't know. I wish there was a way it would actually tell you if you actually got an error in any of these past matches without you having to go through them one by one, because that's kind of something you'd want to know, isn't it? It's not reasonable to have to go through them. Like, if you've actually got an error, that means it's quite critical. But I guess it's up to you to figure that out. It could be that some people are just working with errors. Like, I don't know, using try error exceptions as like condition as a branching logic, which you shouldn't really do, but some people do that. So it's like try this, or just, well, no, that wouldn't throw an error. Well, I don't know. Let's see this one. Rapatrier. Interesting. Yeah, we need to get to the point where we can actually go searching deep for fish without being afraid. Alright, but that will come next. So the big thing I want to change, which I don't even really have time to do right now. I can get started on it. Just as long as we don't break our code like we did last time. I still don't really know what to do about this. So what I want to do is to actually create a pathfinding. Given the start and the goal, I want to find a path to that goal which avoids monsters, and this method will simply return the first step. The first location we should go. That's what I want. So that will be like I mean, A-star search makes sense. So what would the heuristic be? Just like Euclidean distance? No. We're not thinking in terms of distance, we're thinking in terms of steps, aren't we? Discrete steps. Trying to get somewhere in the minimum number of steps. Let me have a think about this. Yeah, at the end of the day, what you're trying to minimize is number of turns. You can go 600 units in one turn, so if you can go... The idea is we look at all the spots we can go to along the circle, and we'll split that, subdivide those points. So we're not going to take every single point on the circle because there's too many. So we subdivide it by some factor. Alright. So basically our neighbor function is from a given position of a drone, we can go to any of these spots on the circle. We want to pick and for each neighbor, yeah. So do that. And for each neighbor, to check if it's a valid neighbor, we have to check two things. One, we have to check the line segment from us to that location and check whether it will cause a intersect with a monster's radius. You have to do the calculation to work out if we'll get aggroed, if we'll get emergency'd, if we get caught by the monster. And then when we arrive at that spot, we have to do a second geometry check to check if the monster can now, when he does his move, if he can now reach us. Okay, so this is constant time geometry checks, but it needs to be, it's not constant time, you have to do it for the number of monsters, but yeah, for each monster you do that. And that determines if it's a valid neighbor or not. So basically we run A star, it will pick the best moves. So what should happen is that we, instead of fleeing from monsters, we'll still try to go to our target, but we'll perturb left or right, hopefully, to get around them. And we'll always prioritize trying to get the best angle towards the goal without getting caught by the monsters. And if we're trying to go to the top, then we want to modify this because we don't want to go for a specific point. Instead, we're happy to go to any top spot. So what do we do there? We're basically saying our goal is we just have to modify our goal function depending on whether we're going to a whole line of points or a point. So a goal might be a point, or it might be a whole region. So yeah, we need to develop this generic pathfinding method, and that can be used for so avoid monsters will not be a method of its own. It will just be baked into the pathfinding. So this decide orders will tell them whether to head to the surface or head for a fish or whatever. But the pathfinding will do the avoiding monsters passively. That's how it should be. So head to surface will use the goal, we'll use that goal, and hunt fish will use now when we're picking a fish, we could still pick the ones which are physically closest to us. Or we could, for each of these fish, run the A-star search. Now, I don't know how expensive this will be, so we'll have to wait and see. And use that distance. So we'll return the number of steps to get there. And the next step. So closer fish in general will have a shorter number of steps to get there. But if we know that there's a bunch of monsters in between us and a fish, then that just makes it a much longer route to get there, by our assumption. So it might help. I'm happy with this rank though, at the moment, given the naiveness of our monster handling code. So, one would hope that we get a massive boost from doing this whole pathfinding thing. It is what other people have told me they're doing, and it is kind of obvious thing to do, although the details are not obvious. There's different ways you can handle the details, but the general idea of, you know, running a path that avoids monsters is, like, that's what you should eventually be doing. Let's see if Ku's bots have changed much. I assume that they're doing roughly the same thing. Oh, huh? So Ku, I'm pretty sure, goes for, ooh, 6 monsters here, but they're all in the lowest band. Ku goes for, tries to sweep the map, so I'm getting all these early bonus points, because why not? What happened here? Ku's code crashed. Make a note of that. I think I don't know who might already be aware of this, but I'll copy that seed just in case. In fact, well, it's visible in the video at least. There's the seed there, Ku, if you happen to be watching this. Although if you're in chat at some point, I'll mention it as well. Your code outright crashed on this map. Both drones got caught by the monsters. I guess maybe the code was just really optimistic and never expected to get caught. Which would be surprising because Ku's in the top 200, so okay. Anyway, let's try the seed. Alright, so orange. Not bad, 20 points, that's fine. Alright, let's set up the framework for this whole pathfinding thing then. This one, I want to border these a bit better. So border stuff, the moves, weights stuff, that goes up there. And then here we want the A-star search because that's going to be used by all the methods below. So define. We'll just call it path from a start. So the goal will either be a position call it goal. We'll call it a goal pos for now, but we would need a boolean to handle that. So say monsters never leave the map. So if the goal is how do I describe this? Full horizontal? Goal is horizontal, let's just say that. Equals false. So if we're specifying that we want to reach a goal height, rather than a pause, we still give a pause. Do we? It's not quite... Alright, it's a bit weird the way I've done this. I think the proper way, normally you'd have two methods. One which is a wrapper around the other. So if you're looking for height, then you would actually call... No, but either way, you'd need the goal check to... Oh, okay, I think the proper way is to actually supply a goal function. Well, maybe I should do that. Yeah. Supply goal as a function. But wait, you need a... You still need a parameter, don't you? I think this is the proper way to do it, though. So when we're looking for... We make an anonymous function, which is a boolean, which says this is the goal, this is within range of the goal, or whatever. Okay, we'll worry about that later. Alright, so goal function is a function which says, given a position, boolean, output a boolean, whether or not that's a goal or not. Simple as that. We supply that function. Alright. So path is basically going to return distance primarily. Or next step and distance. Yeah, the next step is what we want mostly. And then the distance is kind of like a parameter that will tell us roughly how long it's going to take. I think that's good. Move dist. supply monsters. We get monsters from the creature list. We can just do that. So we're going to be using a priority queue. Might as well go full A-star here. No reason not to. I think this will be good. Because in general, the path will be quite straightforward. It's often going to be a straight line, but slightly curved or something. In those cases, A-star normally massively outperforms Dijkstra. It's only when you're kind of have no realistic heuristic for your goal, that's when A-star can add overhead and Dijkstra is sometimes faster. I have seen that happen, but usually in this we have a good estimation, so that's fine. Alright, from queue import priority queue. Okay, so if we might as well define the heuristic as well. So we've got H for a given location, current, let's say. See, now there becomes a problem. If goal function is purely a function that we have no knowledge of, then we can't have a heuristic because we don't know what the goal function is, what structure it is. We need, okay, go back to what I was doing before. I was trying to be too clever. Let's just say goal pos and is goal full horizontal, let's just say that, equals false. Alright, so then basically we have two cases. Alright, so if is goal full horizontal, then it's just the height equals goal pos dot y. So it's going to be absolute value of current dot y minus goal pos dot y. That's how much height we need to cover. Divide by, do a floating point division. So h is going to be a floating number, floating point. We don't want to do integer rounding because we lose value there, because it is actually things which are slightly further away. We do want our heuristic to treat them as being further away. But if we do integer rounding, then it'll treat them both as being the same, which is not wrong, but it's just not as good. We want our heuristic to kind of prefer, so we'll do floating point division here. So it'll be absolute current divided by move dist. Basically, how many units we can move to get to the height. So it's divided by 600, so yeah. Oh. Hang on. Well, you gotta be precise here, because when it's a horizontal goal, we actually want to get to that goal or above. Although it's generally better to just sit on the goal position, but it's fine if we're above it. We can worry about that when it comes to that calculation, but yeah, whatever. I mean, that's just the answer there. So in general, we would return so it's going to be math dot square root. So it's going to be dist. So it's going to be current dot pos dot dist 2. Remember, it's get pos. No. Current. It's a pos. Current dot dist 2 goal pos square rooted divided by move dist. Okay, so that's the heuristic. I think that'll be very useful. So it's always so in A star, you want the heuristic to always be an underestimate. So you always need at least this many steps. And this is a floating point division. So you're always going to need kind of like the ceiling of this at a minimum to get somewhere. Because you can't move more than 600. So yeah, that's right. Okay, so Q equals right, so the things we need a dist table. It's going to be a hash map. And we'll map start to 0. What else do we need? We're going to need a came from map. Map start to none because it didn't come from anywhere. So the point of the came from map is to be able to retrieve the path, so we'll know where our first move is. Q dot put Alright, so it's a priority queue, so we want to need the priority, which will be H of start, like that, as a tuple. So always take the one with the lowest priority, which is going to be the one with the smallest H value. To begin with, it's just start, but it's the predicted distance. So it's always going to pick the point which is predicted. Let me just spell this out fully. In general, it's this. Dist start plus H star. This of course is going to be 0, but I might as well put it in just to make it clear that I'm taking the distance to start plus the predicted remaining distance from start. That's how you put things into the queue. Came from... Alright, so you do while not queue.empty. It is technically possible for there to be no path to a fish if there's like monsters kind of, if it's in the corner and monsters are surrounding it. So this could be an infinite loop, so we do actually have to do a timeout. Because otherwise there's just too many possible states, aren't there? It's 10,000 by 10,000. We could be visiting all of them. So we need to set a timeout. We'll do that once we've figured out what's a good time. Let's say timeout. For now it's fixed. Let's say it's like turn limit. This makes more sense because we can actually comprehend what this means. This means we're not allowing anything which takes more turns than this. So let's say what's sensible here. How long would it take to get from one corner to the other? It would be so it'd be like square root of that's the distance, and then we want that divided by 600. So it'd take 23 turns to get from one corner to the other. But if we're allowing for monsters, so a bit of deviation, in the worst case we would go like, I don't know, all the way to the bottom and then all the way to the side, which we do like that. So it'd actually be 10,000 divided by 600 would be like to get to the bottom, and then should we just say 32 then? It's a nice round number, very round number. So basically, if we ever see any nodes of distance more than 32, then we don't put them in the map, so we don't expand them. So this should basically not infinite loop. We only ever go 32 turns in any direction. That's still quite a lot of branching, because 32 turns in any direction, so that's basically... How many neighbors do we have? We might need to make that smaller. Okay, whatever, we'll worry about this later. Well, not q.empty. Alright, I might actually need to finish soon, so I don't want to start this logic. Just say break for now. Alright, so let's leave that there. We can actually reduce that, let's just say 16. Don't really want to be... Okay. Alright, I think that was a good session. We've only got 2 and a bit days left. I always find myself wanting more time, but I think tomorrow I might be able to put in a much longer session because my gym subscription will end, and I'm not going to extend it because I'm not going to be here much longer. So if I'm not going to the gym tomorrow, then that means I can just go right into the evening. I won't be as healthy, but we will get more coding game done, so that's the important thing. So yeah, I can have a long sit down, do lots of good algorithms and stuff. I think this whole A-star search could really make or break, because we should be doing it. It's just a question of what parameters, how many neighbors to include, what limits to set, how close we're allowing ourselves to get to monsters. Is it just straight up like you're allowed to be 1 square away, 1 individual unit away from a deadly spot, as long as you know you won't die in that spot? Are we allowing that? I'm going with yes to begin with, because if you've calculated that they literally cannot destroy you, but then by rounding errors and stuff, maybe they might still get us, I don't know. Do we want to live dangerously? It seems like people are living somewhat dangerously. Ku got caught, which was interesting. So, but you can't. But I mean, Ku did say you can never guarantee not getting caught, because you could just run right into a spot where you give the monster a chance to step into you. So you can't, unless you just move so conservatively, like slowly and putting on your lights when you're moving faster or whatever. But you can't take that. You gotta take the risk to get the points. So yeah, okay, finish there. How long was that session? Just over 2 hours. All right. Alright, well, see you tomorrow then. Today I may be playing Pokemon Gold for the challenge, I'm not sure. We'll see if the rules get figured out. Okay, bye-bye. See you tomorrow.